Welcome to C++ Club. This is meeting 146 that took place on the 31st of March 2022. March committee mailing is available. It contains some existing papers with new revisions and some new papers. Let's have a look at some of them. T0009 stud mdspan. Revision 16 of this paper contains major wording revisions based on WG feedback. To remind you, this paper proposes adding to the C++ standard library a multidimensional array view mdspan, along with classes, class templates, and constants for describing and creating multidimensional array views. It also proposes adding the submdspan function that slices, returns an mdspan that views a subset of an existing mdspan. End quote. At this point, why not make a bet on which revision of this paper gets into C++ 26? I say 21. P1684 stud md array. A companion to the previous paper, this one proposes an owning equivalent of mdspan. P2558 add ampersand, the $, and the backtick to the basic character set. Steve Downey wrote this paper in which he says, quote, WG14, the C Standardization Committee, is adopting N2701 for C23. This will add these symbols to the basic source character set. C++ should adopt the same characters for C++ 26. End quote. Previously, Corentin Jabot discussed the usage of these characters in other programming languages in his paper named For a Few Punctuators More. P2565, supporting user-defined attributes. Brett Brown of Bloomberg proposes to add support for user-defined attributes. At the moment, compilers warn you if they encounter an unknown attribute. And at the same time, they are allowed to define compiler-specific attributes, like clang no sanitize undefined, for example. Because of this, cross-platform libraries often have to resort to dances with macros to support code that depends on a vendor-specific attribute. The author proposes to keep the unknown attribute warning, but allow a new syntax for user-defined attributes. It would use an attribute modifier extern. So it would look like extern, GNU access, and then some attribute. This is an example of a proposed external custom attribute. The author chose the extern keyword for this because, I guess, this keyword has too few meanings in C++ and could use one more. Since attributes are built into compilers, it's not clear to me how one would define a custom attribute. Next, we have a post by Bryce Lelbach titled "It's Time for New C++ Leadership." Bryce writes, quote, C++ is at an inflection point. The C++ committee has been successful over the past decade. Yet the landscape has changed, and we must adapt to be successful in the future. We need engaged new leadership to address the challenges we face, and to build the next generation of C++ leadership. I, Bryce Adelstein Lelbach, am seeking the US nomination for the position of ISO IEC JTC1 SC22 WG21 convener to provide such leadership. End quote. Bryce names several problems with how C++ is being developed. Quote, the C++ committee and the number of proposals we receive has grown tenfold over the last decade. For the last 6 years, we have had a significant backlog of papers waiting for review. In some cases, papers wait years to be reviewed by a subgroup. As Bjarne wrote in PO 977, quote, "Most people on the C++ committee are working independently towards non-shared goals. We are 300 individual authors, not one team. We lack focus and a shared set of priorities." End quote. Bryce proposes steps to alleviate the situation. Regarding the new ways of working that emerged during the pandemic, he says, quote, "Our heavy reliance on face-to-face meetings seems outdated to the next generation of programmers who are used to modern collaboration tools that have become prevalent over the last 2 decades." End quote. He wants to assure that, quote, "remote attendees have an equal seat at all future face-to-face meetings." End quote. This is going to be one of the biggest challenges. Among other things, Bryce wants to unify the currently scattered infrastructure under the isocpp.org domain. One of his most important promises is address the lack of diversity and inclusivity. Quote, "The first step in fixing a problem is acknowledging it. The C++ committee and community is not as diverse or inclusive as it should be. This threatens C++'s long-term legacy. As a convener, diversity, inclusion, safety, and growing the next generation of C++ committee leadership will be my top priorities." End quote. Ambitious goals, and it'll be interesting to see how it goes for Bryce and the committee. Xmake package management. This article describes package management in Xmake using vcpkg and Conan, and compares it to what's available in Xmake. It also introduces Xmake's standalone package manager Xrepo. I'm still amazed at the quality and capabilities of Xmake. We lament about how difficult it is to bootstrap a C++ project. We have entire tools that bootstrap Xmake projects. But here it is, an easy-to-use and amazingly capable build system, and nobody seems to know about it. Xmake is the de facto standard, but teaching it to students is akin to starting a modern C++ course by explaining pointers. Xmake could be an ideal student-friendly introduction to build systems, at least for their toy projects, to avoid scaring them away before they even start learning C++. NFT pointer. I only later learned that this was an April Fool's 2021 joke, but still it's good. Non-fungible tokens, or NFTs, are a scam built on the blockchain technology. There are many articles explaining this latest high-tech, planet-destroying pyramid scheme, so I'm not going to go into that. Instead, let me tell you about this excellent project that highlights the craziness from the C++ point of view. Behold, NFT pointer. Quote, C++ stud unique pointer that represents each object as an NFT on the Ethereum blockchain. For an April Fool's joke, this is quite a sophisticated one, and I think it works, sort of. This is a code snippet. Example. Moving between two NFT pointers. First, you make NFT of a type cow, for example. Then you create another NFT pointer of the type animal. And then you assign the cow NFT pointer, or rather move it into the animal pointer. Quote, this transfers the non-fungible token, the token ID, representing the cow's memory address from pointer 1 on OpenSea Etherscan to pointer 2 OpenSea Etherscan. End quote. So yeah, it works and is completely bonkers. I especially like the why section. C++ memory management is hard to understand, opaque and not secure. As we all know, adding blockchain to a problem automatically makes it simple, transparent, and cryptographically secure. Thus, we extend std_unique pointer, the most popular C++ smart pointer used for memory management, with blockchain support. Written in Rust for the hipster cred. Made with love by a blockchain expert who wrote like 100 lines of Solidity in 2017, which didn't work. The performance section doesn't disappoint either. Quote, NFT pointer has negligible performance overhead compared to std_unique pointer, as shown by this benchmark on our example program. Std_unique pointer, 0.005 seconds. NFT pointer, 3 minutes. The project is very thorough and even has a link to a white paper, which is indeed a sheet of white paper in a PDF format. Next, we have comparing floating point numbers is tricky. This is an old article from 2017, but it's still useful and provides a good illustration of the problems with machine representation of floating point numbers. Good things to remember. First of all, floats cannot store arbitrary real numbers, or even arbitrary rational numbers. And since the equations are exponential, the distance on the number line between adjacent values increases exponentially as you move away from zero. Over the course of this article, the author develops and improves a function to compare two floating point numbers. He starts with this code, which I've seen many times in our codebases, and explains why it's wrong. This is taking a difference between two floating numbers, taking its absolute value and checking that it's less than or equal to float epsilon value. Quote, "We would hope that we are done here, but we would be wrong. A look at the language standard reveals that FLT epsilon is equal to the difference between 1 and the value that follows it. But as we noted before, float values aren't equidistant. For values smaller than 1, FLT epsilon quickly becomes too large to be useful. For values greater than 2, FLT epsilon is smaller than the distance between adjacent values. So the condition will always be false." End quote. What about Boost? Boost has floating point comparison API, but the author explains how it is also not quite correct. He then arrives at ULPs. What about ULPs? Quote, "It would be nice to define comparisons in terms of something more concrete than arbitrary thresholds. Ideally, we would like to know the number of possible floating point values, sometimes called units of least precision, or ULPs. ULPs? I'll go with ULPs. Between inputs. If I have some value A and another value B is only 2 or 3 ULPs away, we can probably consider them equal, assuming some rounding error. Most importantly, this is true regardless of the distance between A and B on the number line." End quote. The author emphasizes the fact that ULPs don't work for comparing values close to 0, but that can be handled as a special case. The main takeaways from this article are: when comparing floating point values, remember, FLT epsilon isn't float epsilon except in the ranges of -2 to -1 and 1 to 2. The distance between adjacent values depends on the values in question. When comparing to some known value, especially 0 or values near it, use a fixed epsilon value that makes sense for your calculations. When comparing non-zero values, some OLPS-based comparison is probably the best choice. When values could be anywhere on the number line, some hybrid of the two is needed. Choose epsilons carefully based on expected outputs. This article was adapted from Bruce Davison's article comparing floating point numbers 2012 edition. The Google test macro assert near uses a combination of OLPS and epsilon-based comparisons and is the best way to compare floating point values in tests against an epsilon difference. David Goldberg's article, What Every Computer Scientist Should Know About Floating Point Arithmetic, is a required reading for all programmers. A web-based version is on your screen right now. A related article by John D. Cook, called Floating Point Numbers Are a Leak Abstraction, points out a few cases when floating point numbers don't behave as expected. Quote, floating point numbers, the computer representation of real numbers, are leaky abstractions. They work remarkably well. You can usually pretend that a floating point type is a mathematical real number, but sometimes you can't. The abstraction leaks, though not very often. End quote. Herbie. Herbie is a neat tool that simplifies arithmetic expressions to avoid floating point issues. As you can see, it optimizes an equation to minimize errors. Quote, Herbie detects inaccurate expressions and finds more accurate replacements. The left expression, which is square root of x plus 1 minus square root of x, is inaccurate when x is greater than 1. Herbie's replacement is accurate for all x's. End quote. Herbie can be installed locally or used from the web demo page. It is programmed in Racket. Never heard that before. It looks like a Lisp-like language for language processing. Binary number representation cheat sheet. Hacking CPP provides a useful cheat sheet for floating point number representations. It covers signed integers, unsigned integers, and floating point numbers of different sizes. Very useful. Qt Creator 7 has been released. Even if you don't use Qt, this is a great general-purpose C++ IDE, which is now based on ClangD, the Clang daemon, using Language Server Protocol. Debugging with GDB. The Incredibuild blog has another interesting and useful article called A Step-by-Step Crash Course in C++ Debugging without IDE, Empowering the Terminal by Using GDB. Written by Adam Segoli-Schubert. It covers the basics of GDB command line interface and its text user interface mode. The Reddit thread participants seem to have trouble understanding why, in the era of ubiquitous C++ IDEs, would anyone want to use a terminal-based debugger. Lucky people, they must never have had to inspect a crash dump over an SSH connection to a Linux server. Unlib, a lightweight header-only dependency-free C++ 14 library for ISO units. The author, SBI, from Berlin, wrote yet another physical units library that supports SI ISO units and requires C++ 14. It's header-only and comes under Boost license. Quote, a minimal header-only C++ compatible SI unit library, providing quantities that behave like arithmetic types and feature physical dimensions like power, scaling like kilo, and tagging of units. If your code has to deal with physical units, you can use this library so that the compiler checks your usage of dimensions and your formulas at compile time. End quote. The library features user-defined literals, so you can say 1._kilogram 9.81_m_p_s2. Or, for example, 1_h for hour. It allows deriving units from the basic set. So you can have an electrical charge unit that uses multiplication of units of current and time. There is also support for ratios and creation of scaled quantities from basic ones. For example, using milligram as unlib milli of unlib gram, or using kilogram as unlib kilo of unlib gram, or using ton as unlib kilo of kilogram. The author says in the comment, humans don't use megagram. The library supports tags for when different quantities, which must not be confused, are represented by the same physical unit. Unit conversions are supported by various casts. Quote, there are 4 different kinds of casts available. Value cast allows casting between units with different value types. For example, seconds in int versus seconds in long. Scale cast allows casting between units with different scales, like seconds and minutes. Tag cast allows casting between units with different tags, like active and reactive power. And quantity cast allows casting between units where value types, scales, and tags might be different. End quote. So it looks like a very useful dimensional analysis library. There is similar work available, like for example the units library by Mateusz Busch, which is a subject of standardization effort. This one requires C++20, uses concepts, and comes under MIT license. This library uses literals, but also allows you to specify units as multipliers. Boost Units by Matthias Schabel and Stephen Watanabe implements dimensional analysis in a general and extensible manner, treating it as a generic compile-time metaprogramming problem. It uses Boost MPL and is slow to compile, but allows you to define your own unit systems. And Units by Nick Holthaus is a compile-time header-only dimensional analysis and unit conversion library built on C++14 with no dependencies. It comes under MIT license. Each unit has its own type. Literals are supported, and unit conversions and manipulations are very fast and efficient. Next we have a tweet by Martin Horzeniowski. He tweeted, as we all know, stud-vector of bool keeps causing endless issues. But did you know you can use stud-basic string of bool instead, avoiding the terrible proxy objects? You even get a small vector optimization for free. Apparently there is also a Stack Overflow question about that. It seems like the idea might work, but you still shouldn't do it. Some of the tweet replies were Jan Wilmans. Can somebody get people like this away from the keyboard before they hurt themselves? And Michael Case. Somehow I equally love and hate this tweet. That's it for today, and I'll leave you with some amusing stuff I found. This one's on Twitter. Molly's Truth tweets, The plural of regex is regrets. Yep. Next, we have a photo of an exam paper with the answer crossed as incorrect. The question reads, name and describe the 5 key phases of software development. And apparently incorrect answer was denial, bargaining, anger, depression, and acceptance. Yeah, I can feel that. And finally, a quote from Twitter by Kyriakos Kapakoulak. I learn from the mistakes of people who take my advice. That's it. Thanks for joining me. Until next time. Bye-bye.